Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our core C and core.h, the header file and the source file that is going to contain a lot of the source code or a lot of the functions that you might use in future projects. This is part of a larger series focusing on string and file I/O. We want to take a look now at some of the functions that we did not yet bring into our core.c, particularly some of our string functions. And we'd like to focus in this video on three functions in particular: the string length, string upper, and string lower. So the first thing that we want to do is go ahead and copy the three prototypes or function signatures over into our core.c. I like to keep them roughly in the same location with respect to the prototypes, so keep the order the same. Go ahead and remove the semicolons, and then go ahead and expand out or stub in, I guess you could say, these functions. And note in this case, that all three of these functions return an integer. So the first thing that we want to do is we want to go ahead and create a results temporary variable. You could call it count. That would also be fine. And then, of course, we want to go ahead and initialize results. And then before we forget, we want to go ahead and return our results. So you can go ahead and copy these three lines into each one of our functions. Now remember, we've gotten away from the exit success and exit failure for right now because it makes more sense to provide some sort of other usable feedback back to the calling function. In this case, we'll take a look at our string length function. And so the idea is that that string length function may simply measure the length of the string. In other words, it counts the number of characters until it reaches the end of string. And so the logical return value here would simply be a count of the number of characters in the string. So let's start with this one. And so to begin with, what we want to do is we want to set up a while loop. And remember, we start off with result 0 or index equal to 0. And so what we can do here is we can simply say the while source square brackets results is not equal to the end of string. Then what we want to do is we simply want to say results plus plus. Now, if you think about it, when the string is essentially comprised of only an end of string character, in other words, there's no characters, we don't in fact want to count the end of string character in the total length. So if you were to work through this example here, if the while loop, if the first character in the source was actually an end of string, in other words, it triggered exiting the while loop, then results would be 0, and that would make sense. If the source had one character in there and then followed up with an end of string character, we would expect this while loop to run once before terminating. So in this particular case, then we want to simply return whatever the results happens to be. And that will tell you how many valid characters or non-end of string characters there were in your string. Now, continuing on with that, we want to look at the string upper and string lower functions. They're going to leverage this as well. They're basically going to have two input arguments. One is going to be the destination, which is a modifiable by reference variable. In other words, we can change the values in the destination, and a constant string. In this case, it's called source. And the idea is we want to loop through the source, and wherever we find a lowercase character, we want to convert it to an uppercase character. How do we determine that? Well, I've provided you with the link to the ASCII table in the Wikipedia site And we'll just briefly take a look at this, and you'll see that lowercase and uppercase letters are grouped together. So make a quick note here, for instance, that the ASCII value corresponding to the capital letter A corresponds to the decimal value of 61. Capital Z corresponds to 90. Lowercase a corresponds to 97. And then lowercase z corresponds to 122. So the question becomes, if we want to convert a lowercase a to an uppercase a, how do we do it? Well, what you can do is you can take a look at the decimal value, which is 97, and you simply subtract 32 from it, and you get 65, and you convert that back into a character. So basically, the relationship between a lowercase and an uppercase value is simply subtracting 32 from the lowercase value and vice versa. So you add 32 to a capital A to get its lowercase equivalent. Okay, so how do we go about doing this? Well, you want to keep that page open because we're going to reference it a couple of times. And what we want to do the first time around is we want to convert a source string into its uppercase equivalent. So you want to make a quick note here that to convert to upper simply means add 32. And likewise, while we're here, we might as well make a quick note of it, that if you want to convert to lowercase, rather, my apologies here, if you want to convert to upper, you want to subtract 32. And if you want to convert to lower, so convert to lower, you simply add 32. All right, so no big deal. Let's get this set up. Let's we want our results here to keep track of how many letters we convert. Okay, so even though it seems a little unusual to keep track of this, if no letters were converted, then you may not need to make any further changes downstream in your code. So we're going to go ahead and keep track of the number of results. Well, to begin with, what we're going to do is we're going to set up a while loop. And in this case, our while loop is going to simply use our source. But this time around, we will need another temporary variable. We're going to go ahead and call this one index. So while source is not equal to end of string, we want to convert the values. Now, first thing we want to do is we're going to create a temporary variable here called index, and we might as well go ahead and initialize it before we forget. So we're going to say index is equal to 0, and this is going to allow for us then to loop through the source. Now, we said that we want to subtract 32 from any lowercase value in order to be able to get its uppercase equivalent. However, we don't just blindly want to subtract 32. We only want to subtract 32 if, in fact, the value of the letter or the character stored in that location in source happens to be greater than or equal to 97 and less than or equal to 122. So we want to start off with an if statement. It's going to be a compound if statement. And we're simply going to say if source square brackets index greater than or equal to 97 and source square brackets index less than or equal to 122. And if under this condition, then essentially what this means is we have a lowercase letter, which needs to get converted. So converted. And how do we do that? Well, it's fortunately just as simple as it seems. So if we can compare characters using numeric inequalities, then you'd be surprised to also find out that we can do numeric addition and subtraction, numerical operations on characters as well. So in this particular case, what we want to say is destination square brackets index, because essentially these are going to be parallel arrays, are going to be equal to source square brackets index minus 32. So for instance, if it was 97, 97 minus 32 is going to get us 65, which means that we're going to convert a lowercase a to an uppercase a. Now, under the else branch of our if-else statement, we want to simply do no operations on the source value. In other words, we simply want to assign it to the destination. So in this case, then we would simply say destination square brackets index is equal to source square brackets index, and no change. The last thing that we want to do, and it's the reason for having the results variable, is that inside the true branch of the if statement, whenever we do make a change to our source value when we're copying it to the destination, we simply want to keep track of how many there are. So in this case, we're just going to say results plus plus. And so now our function will return the number of characters that have been changed, but also it will update this character vector since it is being passed by reference. Now, let's do this one more time just to make sure that we're all clear on it. Down here in lower, we want to take every capital letter and we want to convert it to its lowercase equivalent by adding 32 to it. So the first thing we want to do, since we've learned from the last time, is that we need to have a temporary variable called index. And just like before, we want to set up a while loop that allows for us to loop through the source using the index variable. And while it is not equal to the end of string character, we want to check to see if the source square brackets index, if in fact the source square brackets index is greater than or equal to 65, and source square brackets index less than or equal to 90. Once again, a compound condition. Under the else, we want to simply do nothing or no change. So we'll go ahead and handle this real quick. It's going to be destination square brackets index is going to be equal to source square brackets index. And then in the true branch of the if statement, what we want to do then is we simply want to map the source to the destination, in this case by adding 32 to each one of the source values. And then lastly, we want to increment the results. Now, I've intentionally made a bug here. I'm going to encourage you to pause for just 1 second to see if you can find the error before I show it to you. So this is in the back of your mind where your Jeopardy theme music needs to be playing. And then I'm going to give you just a second to see if you can find it. Perhaps pause the video. Any guesses? Well, it turns out that I have successfully written an infinite while loop, meaning that I did not increment the index. So it's important to remember that every time you have a while loop, something needs to change inside the while loop, or something about the condition rather needs to change. In this case, we need to change the value that we're looking at in the source. And to do that, we simply increment the index. So in both of these, after the if statement, doesn't matter which branch is executed, we want to simply increment the index. Now, there's also a second mistake, if you would, that was made, in that in this particular example, we would pass a source string and we would read all the values up to the end of string. However, we would not read the end of string. So essentially what happens is we remove the end of string character from a valid source string when we are copying it over to its destination. And so to fix this, outside of the while loop, right before you return, you simply want to say destination square brackets index is equal to your end of string character. Once again, same in the string lower. Once you have looped through the source index, you essentially are ignoring this end of string character. So if you forgot to do this, what would happen is you would provide the string lower a valid source string, but you would get back an invalid string because it would not have the end of string character on it. So what you would do here, once again, is say square bracket destination square brackets index is equal to your end of string character. Now, we've seen this now a couple of times where you need to append this end of string character onto the end. Now, let's see if we can't go about testing this. So this is going to be an easy function for us to test, because what we're going to do now is we're going to first go ahead and build it to make sure that we didn't make any mistakes in our core.c. And looks like we're fine. So I'm going to go ahead and bring this over here to the side, sort of leave this as a reminder of what we're trying to do. And then inside the main, what I would like to do is I would like to convert a couple of strings just to see how it works. And what we can do is, rather than have a bunch of fancy arguments and things like that, what I would suggest that we do is that we simply create another string demo, or we utilize the one that we already have. So we can either create a second string demo, or come down here, and now inside of our string demo, we can simply add a little bit more code here. And so another example, for instance, so we're going to call this then our sample 03 and our sample 04. So we're going to have char sample underscore 03, and we'll keep it at 10. There's nothing wrong with that. And then char sample square brackets 04. And you can choose, for instance, to go ahead and comment out some of this code so that we don't have multiple examples running at the same time. This is essentially just meant to be a play space for us. So I'm going to temporarily comment this out. And then what I would like to do is I would actually like to use this sample 03 and sample 04. Instead of hard coding a value here, what I'd like to do is I'd like to make this a little bit more interactive. And so I'm going to go ahead and say, now printf, please enter a string less than 10 characters, followed by a new line, and then a scanf. And for that scanf, we're going to use a %s. And then we are going to store it in our ampersand sample 03. Now, we're basically going to let the user put in whatever they would like. And then what we're going to do is we're going to run it through our string upper and our string lower function. And so what we can do here, we have a temporary variable of n and index. Why don't we go ahead and grab one more? So we'll say int results. And at this point, what we'll do is we'll simply say results are going to be equal to, and how about if we convert everything first to uppercase? So string upper, and this is where we are going to use our sample underscore 04 and our sample underscore 03. Now, we could just as easily have called this source and destination. In other words, we could have picked two different temporary variables. That's no big deal there. But then what I'd like to do is I'd like to follow this up with a printf, and I'm going to say %s converts to %s by changing %d characters, and follow that by a new line. And then for the first placeholder, we are simply going to put our sample 03, the one that's collected from the user. For the second placeholder, we'll put sample 04. And then for the third placeholder, I'm going to simply put in whatever the results were. Now, we might as well go ahead and do this one more time. And this time around, instead of doing upper, we are going to use lower. And once again, I'm going to use another printf statement just to print out then the new string, the old string, and also how many characters were in fact changed. So I'm going to go ahead and build this. If you recall, the switch for this particular function was /string_demo. So I'm going to clear my command window. I'm going to go ahead and run my core demo with my string_demo switch. And you'll see that it prompts us then for a string. I'm actually just going to go ahead and use my name. And you'll see that Gregory converts to capital letter Gregory by changing 6 characters. But if you noticed, we had a little bit of a weird delay right after this first output. And so it's really good that this happens, because occasionally your code may pass compile, but then has an issue at runtime. And this is a really good example of this. Essentially, Windows 10 swallows the crash, but you notice that we only printed out the first line where I convert to the capital letters, to convert all the letters in my name to capital letters or uppercase. So if you come back here, we know we've got something going wrong in our string lower function. And if you're very careful, you'll note that I've declared my index. However, I forgot to initialize it. So in this case, then it's going to be index is equal to 0 because we were trying then to use it inside the while loop. And so if I build this one more time, and then I run it, I'm once again going to be prompted for some sort of string, and you'll see that Gregory converts to all capital letters by changing 6 characters, and it converts to lowercase by changing 1 character. Now, just a quick little change that I'd like to make back here in my string demo to make it a little more interesting, because maybe you want to run this more than once, is I would like to introduce one more thing here, and that is going to be a flag. I'm going to basically have a flag that we're going to continue to check with a while loop to see whether or not the user is done. So I'm going to have one more temporary variable. I'm going to call it done, and I'm going to initialize done to 0. So done is going to be equal to 0. And then I'm going to set up a while loop, and while done is equal to 0, I want to simply prompt the user to enter in a string. Now, this, of course, will become quickly aggravating if we don't give the user some way to exit out. And so what I'd like to do here is to have them please enter a string less than 10 characters or exit. So in other words, basically, if they type in the magic word, then what we want to have happen is we want to exit out of this while loop. And so what you can do now is you can take the value of your sample 03 using the string compare I function. And what we're going to do is we're going to compare sample 03 with the word exit. And if there are no differences between the two, then we simply say done is equal to 1. And if they do not match, then we continue processing the string. So in this case, what I'm going to do is close my curly braces and then simply shift the code, so that the only time this code runs is as long as the user does not type in exit. And so just a little minor change to make this a little more interesting. So I'm going to build this one more time. I'm going to come back out here to the command window. I'm going to go ahead and run my string demo. And so I'm going to type in hello, and you can see how many characters get changed when you type in capital H, lowercase e, LLO, likewise this way. And then also, if you just simply type in something that is a non-character, you'll see that nothing gets changed. Doesn't matter whether you go to upper or lower. And then lastly, if I hit exit, then I will get kicked out of the while loop. So hopefully you found this video useful. And once again, to summarize, basically what we did is we built our own string length function. We also built a string upper and a string lower case, which allows for us to switch between cases using the ASCII values. We also learned how to return a value that keeps track of how many changes are made, in this case, in our parallel array, our destination array. We also ensured that we were returning strings. And then lastly, we saw what happens when you make a mistake that survives compiling, but not our runtime. So you saw that delay. You knew that something happened because our string lower did not run correctly. So once again, hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me. And thank you for watching.